And let's start by taking a look at the this keyword outside of any function whatsoever. So just outside here in the global scope. And so we get that the this keyword in the global scope is simply the window object. So that's the global object that we just saw before, remember? And now let's do the same, but inside of just a regular function call. So we're going to use our old friend calc h here. So let's log to the console just the usual result so that we're actually doing something here. But then what we're really interested in is taking a look at this keyword. So let's now call this function. And so let's see. And now the result of taking a look, so at logging the this keyword, is undefined. Okay? And so what that means is that inside this just regular function call here, the this keyword will be undefined. And that's because we are in strict mode. Remember that in sloppy mode, it would be also the global object. So in this case, the window object. But you already know that you always should use strict mode. And so then in a regular function call like this, the this keyword will simply point to undefined. And with a regular function call, I simply mean a call of this function without the function being attached to any object. So without having an owner, so to say. But now let's see what happens if this function here was an arrow function. So let's just copy this. So calc h, both here and here, arrow. And let's call this one with a different value. And now think about the rules that we learned in the last video. So what do you think the this keyword will be if this function is an arrow function? And actually we still need to do that. So birth here. And so now it is a legit arrow function. And so once more, what do you think the this keyword will now be? Think hard about it, and then let's check. And so it is window. So that's a little bit weird, maybe, right? So why is that? Why is the this keyword undefined in this function, but window in this function? Well, it is because the arrow function does not get its own this keyword. So instead, the arrow function simply uses the lexical this keyword, which means that it uses the this keyword of its parent function, or of its parent scope, so to say. And in this case, what is the lexical this keyword? So what is the this keyword in the parent scope of this function? Well, it is window, because window is the this keyword here in the global scope. So right here. Okay, that's why I started by showing you this one here. So in this case, this keyword here will simply point to the this keyword in the global scope. And so therefore, it will point to window. Unlike here in this normal function, which does actually get its own this keyword. It simply is undefined here, but it is its own this keyword. While this one here in the arrow function is actually not the this keyword of this function here. Okay, it is simply the this keyword of the parent scope. And that happens to be the window object in this case. In the next video, we will see some more real-world implications of the fact that the arrow function does not get its own this keyword. Now next up, let's try to use the this keyword inside of a method. So let's quickly create a Jonas object here, just with a birth year, 1991, and then again our calc h method. And so remember that this is basically now a function expression that we need to write here. And now let's log the this keyword here, and then let's call actually the calc h function. For now, just to see what the this keyword will look like. And my hope is that you can guess already what it should look like. So let's save it to see the result. And indeed, it is the Jonas object. So exactly this object with calc h in here. And so it means that's exactly this object. And that's exactly the rule that I told you in the previous lecture. So when we have a method call, the this keyword inside of the method will be the object that is calling the method. And in this case, that's the Jonas object. So Jonas here is basically the owner of the method. That's another way of saying it. And therefore, inside of calc h, this is Jonas. And then we can use that to our advantage to calculate the h here based on the data that is already in this object. And so that's one of the big use cases for the this keyword. Right? Because then we don't have to pass in this data here again. So instead of having to do this again, we can simply use the birth here that is already in the object itself. And so we can use the this keyword to reference that object. And so this should now give us our usual value here of 46. Great. So that's pretty important stuff. And now let's move on just to one final example here in this lecture. So I keep saying that the this keyword will point to the object that is calling the method, right? And that means that the this keyword will not simply point at the object in which we wrote the method. So here we wrote the calc h method inside of the Jonas object. And so we might think that that is the reason why the this keyword points to Jonas. But that is not true. The reason that the this keyword will point to Jonas in this case is because Jonas was the object calling that method. And that's a subtle but very important difference. And let me now show you why that is. So let's create a new object, which I'm going to call Matilda. And let's create a first name. Or actually, we don't need a name. Let's just say year 2017. And that's it. That's all we need in this object. Now, remember that a function is just a value, right? And therefore, we can do this. We can say Matilda.calch should be equal to Jonas.calch. So basically, here we simply copy the calc h method from Jonas to Matilda. And so now when we take a look at Matilda here, then we see that the calc h function is also in here. All right? And of course, it's still also in Jonas, but now we copied it from one object to the other. And this is called method borrowing. So we basically borrowed here the method from one object to the other, and so we don't have to write it in a duplicate way. So now let's say Matilda.calch. And what do you think the this keyword will look like now? And let's get rid of some of these before so that they don't clutter our output here. And you can then, of course, take them back if you want to see them in your own code. But now let me save this and see what the result of this calc h will be. So the h of Matilda gave us the correct result of 20, which is exactly 37 minus 27. And so this means that in this method call here, the this keyword does now actually point to Matilda. And we can also see that here. So here, as we logged the this keyword, we see that it's actually the Matilda object because of this birth here. And so this proves exactly what I was just telling you before, which is the fact that the this keyword always points to the object that is calling the method. And so here, we are calling the method on Matilda, right? And so therefore, the this keyword will point to Matilda, which was the object which called the method. So even though the method is written here inside of the Jonas object, the this keyword will still point to Matilda if it is Matilda who calls the method. Okay, and so that's really important to understand, and it's the reason why I said in the last video that the this keyword is really dynamic. It's not static, and it depends on how the function is called. And we can take this even further by basically completely taking the function out of the Jonas object. So let's create just a variable called f for function, and then say jonas.calc h, and not call it, of course. So we just want to copy now the function into a new variable. And so once more, that is possible because a function is just a value. So we take this value here and copy it here, and of course without calling it, okay? Just like here, where we copied the method from one place to the other, but we did not call it. So here we can take a look at f in the console, and so you will see that it's actually this function. But now, what implications is this going to have for the this keyword? Well, let's just try to call the f function, which remember is the code of jonas.calc. And so now the this keyword should be undefined. And therefore, we also get this error that it cannot read year of undefined. So that's coming from here, because the this keyword is now undefined. And so undefined.year does, of course, not exist. So this happens because this f function here is now just a regular function call, right? It is not attached to any object. There is no owner of this f function anymore here at this point. And therefore, it is just a regular function call, just like here, for example. And so therefore, the this keyword is then also undefined, just like, again, here in this function, which was also a regular function call, just like our f function is now. All right, so again, that's a subtle difference in our code, but it makes all the difference in the result that we then get. And for sure, the this keyword is a subject that confuses many beginners in JavaScript. But hopefully, this lecture and the previous one made it a little bit more clear. Now, we didn't talk about the event handler functions here that I also showed you in the last video, so on the slide there, but I'm leaving that for the advanced DOM section, where we will come back to this. But for now, in the next video, we need to take an even more closer look at regular function versus arrow functions.